Linear inequality equations. They're done the exact same way as if it were an equal sign. They look the exact same thing as if it were an equal sign, except they got an inequality symbol instead. All the work is done except for one different type of answer, different type of problem. Not the answer, problem. So, watch this. Let's do a couple of examples to start off with, basic ones. Remember, the same steps apply. So we're going to solve these and we're going to graph these on a number line. When we do this, we'll show you what's going on with all the symbols. To solve this, it just means get x by itself. To get x by itself, we're going to add 6 to both sides, because the opposite of subtracting 6 is adding 6. We get x greater than or equal to -5. Now we're going to take a number line, and I don't do anything fancy with the number line. I just write down -5, mark a -5. Let me just do some thinking. First off, if I take the -5, I always check the number. Now substitute it in, do we get a true statement? So let's find out. X is now -5. -5 minus 6. Does that equal -11? The answer is yes. What that means is -11 is greater than or equal to -11 because it's equal to it. Therefore, -5 is the solution. So we use a closed circle to represent included. So in other words, if it's less than or equal to or greater than or equal to, you use a closed circle. Now, since it's x greater than -5, you should think you shade the right side, but sometimes it's always worth trying to test the point. So let's come over here and pick a number to the right of -5, which is 0. You substitute it in, you get 0 minus 6 is -6. Is -6 greater than or equal to -11? Yes. It's not near as negative, so it's greater than. That just confirms that you want to shade the right side. So anytime you have x on the left side of your answer, whichever way this symbol is pointing, that's the side that you shade. And it continues on forever. It never stops. So I'm trying to draw an arrow there at the end because it never stops. Now let's take this example. And when you read that, it's -2 times x. So when you multiply, or when you solve this, you're going to do multiplication with division. So I'm going to divide by -2 because that's what's in front of the x. Now before I write that symbol down, 14 divided by -2 is 7. Is -7. We're going to think about this for a second. First off, when I draw my number line, I'm going to represent a -7. Now when I throw in the -7, just to check it, is that a true statement? -2 times 7 is, oh my bad, it's a -7. Don't make that mistake, signs that get you every time. -2 times -7 is 14. Is 14 less than 14? No. So therefore, -7 is not part of our solution. So we use an open circle to represent that. That's so. And to summarize, it's just a less than or greater than, open. If it's included, less than equal to, greater than equal to, then it's closed. Now, you may be tempted to think that you're going to shade the left side because everything's pointing to the left. Well, let's pick a number over here to check it. Let's pick like a -10. So if we take this same equation, throw in the -10, do we get a true statement? Let's find out. -2 times -10 is 20. Is 20 less than 14? Definitely not. So what that means is, if one number fails on the left side of this number, the whole side fails. Let's take a number over here and see if the right side works. +10. So let's substitute 2 or x with a 10, just using the same equation, and see if we get a true statement there. -2 times 10 is -20. Is -20 less than 14? Yes, it's a whole lot less. So since the 10 gives us a true statement, the whole side gives us a true statement. I'm going to shade that right side. Remember, if x is on the left side and we shade the right side, that's a greater than. Here's the rule. This is the only way that inequality equations and equality equations differ. Anytime you multiply or divide both sides of a linear inequation by a negative number, always reverse the direction of the inequality sign. It's got nothing at all to do with the answer. It's the process. If you multiply or divide by a negative number, the inequality sign reverses direction. It's got to be a negative. Multiplication or division. Period. That's the only way that these differ. So now let's do these last two examples, keeping in mind the rule that we just talked about. And I almost always like to keep the x on the left side because it makes the graphing a whole lot easier to do. Here we go. On this one, we need the x term by itself. We got 11 being added, and you get rid of it because it doesn't have an x. We're going to subtract it from both sides. Don't care about addition subtraction. That's going to change. That's going to stay the same. We only worry about if you multiply or divide by a negative number. So left side we have a negative 3x. Right side, when you combine those, you get a negative 24. To solve this, we're going to divide because it's negative 3 times x. And what do you divide by? That negative 3 in front. As soon as you do that, that changes direction. As soon as you do that, and you get a positive 8. Has nothing to do with the answer. It's all about the process. And as soon as you divide, change it. And once again, if you're going to do the number line graph, make an 8 equals means it's included. Greater than, shade the right side. You want to check it right quickly? Pick a number bigger than 8. Let's pick 9. Negative 3 times 9 is negative 27. Negative 27 plus 11 is negative 16. And negative 16 is less than negative 13. This one I'm just going to solve. I'm not going to worry about the graph. You get the idea of the graph, hopefully. Here we go. Nothing to do on the left side. Right side, we'll distribute that negative 4. Do not change that sign. We haven't done anything to both sides yet, let alone multiply divide by negative. Now on this one, normally I would deal with the smaller x term, but like I said with the inequalities, I prefer to keep the x on the left side. So that's what I'm going to do. I'm going to move this x term over to this side by adding 4x to both sides. And we get negative 2x minus 3, still greater than. Those cancel, leaves a negative 4. Now I have to add 3 to isolate the x term, the negative 2x term. Once again, I'm still adding and subtracting, haven't multiplied or divided both sides by anything. Negative 4 plus 3 is negative 1. And then to solve this one, I'm going to divide by, negative 2. As soon as I do that, switch it. And there's your answer. X less than, and negative divided by negative is a positive 1/2. And that's how you solve linear inequality equations.